Hi, in this video we'll be amending our Siemens S7-1200 PLC code to include sending lower height boxes to the left as well as higher boxes to the right, and we'll be doing that in FactoryI, so stay tuned. Welcome back to the third part of this training video for the FactoryI conveyor system. So let's start FactoryI and see where we left off. As you can see, the pallets travel down the entry conveyor and the first one enters the small loader conveyor and transfers right. If we zoom in, we can see the right conveyor runs continuously even when it isn't required. So that's one thing we need to change. But how do we go about doing it? Well, let's zoom in again and take a closer look at what's happening. Now, what we have to consider is the maximum amount of pallets that can be on the right conveyor at any one time. So let's increase the amount of boxes being emitted in a single time frame. Let's stop FactoryI and let's take it down to a low number. Okay, that should be fine. Then let's start FactoryI again. So let's see how many pallets can be on the right conveyor at any one time. Okay, the first one is transferring right while the next one is waiting. Then the next one starts loading and starts transferring right while the previous pallet passes the right exit sensor and is then removed. So it's clear to see that even when the maximum amount of pallets are being produced, the maximum number of pallets that can be on the right conveyor at any one time is 2. So let's go offline using the Siemens TIA portal and amend the ladder logic so that the right conveyor only starts running when it's required. And the way we do that is to count the pallets transferring right and then count down the pallets when they are removed. If the number is 0, meaning there are no pallets transferring right, then we can stop the right conveyor running. So let's add another network in between the outputs network and the transfer network. And this one we will call right conveyor, where we will enter the ladder logic. Okay, insert network and name it right conveyor. Now the point at which the right conveyor should start is when transferring right M0.2 is true, which is just after the pallet is fully loaded. So let's make a start. So we bring down the normally open contact and address it M0.2 and enter. Then we need to add an up-down counter. We can get that from the counter operations and bring that down into the network as well. Now, to avoid any confusion going forward, I'm going to name the counter right conveyor, then select OK. We could also go back and label the other data blocks too, but for now I will only name and change names as I go along, where I think it will help. Now we have to add a PV value for the counter, and it can be anything over 2 really, as that is the maximum amount of pallets that can be on the right conveyor, but I'll just put in 10 for now for demonstration purposes. Now let's download the amended PLC logic to the PLC. I've speeded the footage on screen up a little because it can take quite a while. And then we can go into monitoring mode and start FactoryI. Okay, let's have a look at what happens to the counter value and at what stage in the process transferring right is activated, which is when M0.2 is true and stays true until the pallet has passed the right entry sensor. Then every time transferring right is true, the counter value is incremented by 1, and so on. Now, as the pallets are being removed, they pass the write exit sensor, and when this happens we need to decrement the counter by 1. So let's stop FactoryIO, go offline on the TI portal and make the changes to the ladder logic. Now let's add a branch to the write conveyor network and bring down a rising edge trigger, which can be found under bit logic operations. Let's scroll down to find it. And we'll call it write exit. And after that, we'll select OK. Let's enter the input we use to trigger the countdown, which is input 0.7 at write exit. And then we'll bring down a normally open contact and address it with the trigger's Q to ensure a single trigger on the output. So we'll get the address from the tag list. Let's scroll down. There it is, trig write exit, and then it's Q. We now add a compare function to check the value of the counter. And we only want to count down if the value of the counter is greater than 0. A value greater than 0 would mean there is a pallet on the right conveyor or being transferred onto the right conveyor. So under compare operations, we are looking for greater than. Then we bring it down and select the right conveyor from the list, then CV for its value, and we then enter 0. We then take the arrow and bring it up to the counter's CD, countdown input. When it goes green, then we release it. There we go, sorted. Let's just give ourselves a little bit more space to see the full width of the ladder logic on screen. Okay, that gives us enough room to monitor the counter value. Now let's download the ladder logic to the PLC, then go into monitoring mode and start FactoryIO again. Again, we've speeded up the footage here as it can take quite a while. Okay, we're running, and pallets are travelling along the entry conveyor and going on to the loader. As the previous value in the counter was 5, then as soon as a pallet is loaded and transferred, the counter is incremented by 1 to 6. The next pallet also does the same and the counter increments again to 7. As the first pallet passes the write exit sensor, then the counter is decremented by 1. So as it stands, we'll be going from 6 to 7, then to 6, and 7 again, and so on. Even if pallets stopped travelling along the conveyor, the counter would only decrement to 5, where we started. So we need to initialize it to 0 in network 1 at startup, so that the counter value can go to 0 during operation, so that the write conveyor can be stopped. So let's do that now. Let's stop FactoryIO and go offline on the TI portal. Let's extend the branch, and to initialize the write counter, we need to use the move function. So let's bring that down and enter the value 0 into CV at startup. 0, then select the counter in the list, and then CV. Done. So let's download the program to the PLC and see what happens. Well, we've done this so many times now, I think it's probably becoming second nature to you. Now let's scroll down to the counter so we can view the CV value. Let's go online and monitor the ladder logic. Then as soon as we start FactoryIO, the CV value should go to 0. Let's see, shall we? There we go. CV is 0. Then once the pallets are loaded and ready to be transferred right, the counter is incremented to 1. Then 2 as the next pallet is transferred. So now we will go between 1 and 2 in the counter. 2 being the maximum amount of pallets being on the right conveyor at any one time. Now let's stop FactoryIO and increase the time between pallets travelling along the entry conveyor. 18 should do then. Oops, we don't need that. So we can start FactoryIO again and see what's happening. So the first pallet now travels along the entry conveyor and goes onto the loader. Now it's loaded and it's transferred right. And as it does, the counter value is incremented to 1. Then the first pallet will pass the right exit sensor before another pallet is transferred right. And the counter value is decremented to 0. This means the right conveyor can be stopped as it's not required until another pallet is ready to transfer right. Now if we zoom in, you can see the right conveyor is running constantly. So let's stop FactoryIO and make changes to the ladder logic to incorporate stopping the right conveyor running when it's not required. Just speeding up the footage, it takes a while. So we need to go to the bottom outputs network and add the compare condition, just as we did with the counter to check for greater than 0. Meaning the right conveyor will only run when the counter value is greater than 0. Let's select the counter from the list again, and then 0 for the value. Let's go back online and into monitoring mode, and let's start FactoryIO. However, before we do, we can see that the output for the right conveyor is true because the counter value was greater than 0 prior to us having stopped FactoryIO, before we added the compare condition to the output. So as soon as we run FactoryIO, the counter value should be initialized and set back to 0, which means the right conveyor should not be running. Let's see. As expected, the conveyor is not running. Great. Let's zoom in and see when the right conveyor starts. Okay, the pallet is loaded and the right conveyor starts. If we keep looking, we should see it stop as the first pallet passes the right exit sensor. There we go. And the conveyor starts again when the next pallet is fully loaded. Great. Now let's zoom out and just monitor the ladder logic and see when the conveyor output starts running and then stop running when the pallet is removed. Any time now. There we go. On. And off and on. So let's stop FactoryIO and go offline on the TI portal. So everything is working in the right direction along the right conveyor with the large boxes. So the next thing we need to do is amend the program to allow small boxes to go left and large boxes to the right. For the most part, it's about duplicating some of the ladder logic and just changing tag addresses. So let's go to the top of the ladder logic and work our way down. Okay, in the first network there really isn't much to add, although we need to add another move command to initialize a counter for the left conveyor. But we will come back to that when we know the address of the left counter and have completed all the other amendments. Moving to network 2, loading. There's nothing to do there, so let's move to network 3, which is the transfer network. Now on the first branch, we need to add a few things to detect a small box, so we can transfer left. The way we do that is by saying if there isn't a high box detected, by the time the falling edge trig is made, and by that I mean a pallet passes without a high box detected, then it must be a small box, and therefore we need to transfer left. So let's add in the ladder logic for that. Add a branch just before the high box internal bit M0.4, and then bring down a normally closed contact, which is high box M0.4. Then bring down an output coil, make it a set coil and address it M0.3, which is transferring left. Now once we've done that, we can extend the branch down and add another output coil to reset the high box, otherwise we would never be able to go left. Okay, fine. Let's just change the coil to a reset 1. Now let's move to the next branch in the network. This branch resets the transferring right signal, and we need to create the same branch for transferring left. We'll need to insert it before the busy signal branch, so I'm going to cut the busy signal branch, then enter a transferring left branch. Then we'll paste in the busy signal branch after it. So let's highlight it, and from the edit menu select cut. Now we can insert a new branch for transferring left. So we're looking for the rising edge trig. Let's close a few of these bank instructions. Then we can bring it down. Oops, let's select the add branch symbol, then bring down the rising edge trigger. Okay, let's move it out of the way so we can see the previous rising edge trigger for transferring right. Then we'll name this one R trig trans left and select OK. Oops, where have we gone? Okay, scroll down. And we can rename the previous rising edge trigger to R trig trans right to keep things consistent and hopefully avoid any confusion. Okay, trans right. Okay. Now let's put the input signal in. As you can see, you can almost do this without thinking, as the hard work was done for the high box coding, so we just have to copy what's above and then change the tag addresses to suit. So let's look at the tag list and select input 0.4 at left entry and enter. Then we add the normally open contact and select trans left Q. Okay, scroll down in the tag list. Where is it? Oh, there we go. Then we just need to add a coil to reset transferring left, which is M0.3. And now we just need to paste in the branch we cut. So scroll down and add a new branch, then go to edit and paste. Voila. Now we also need to add transferring left to this branch to energize the loaded busy signal, just as we do for transferring right. So let's do that. Select the edge, then add branch and a normally open contact M0.3 for transferring left. Oops, got the decimal point. And let's close that off. Great, that's it for this network. So let's scroll down. We now need to enter a left conveyor network just like the right conveyor network. So we select network 4, then insert, then name the network left conveyor. Let's make a bit of room again to see the full width of the ladder logic. So we'll try and copy the network above and add the appropriate tag addresses. So we need a normally open contact transferring left, which is M0.3. Then we need an up-down counter. So let's add that. Okay, let's get a bit more room here too. Then bring down CTUD and trans left. I just want to see what I named the previous counter to keep things as consistent as I can. No, that's not right. I wanted to name it left conveyor. So let's rename that. Left conveyor. Okay. And for the PV, it can be anything above 2. I know I put 10 in for the last conveyor, but it's just to show you that the number here isn't that important as long as it's more than 2. So I'll put in 8. Then, like the previous network, right conveyor, we need to add a rising edge trigger and a compare function. For the rising edge trigger, the CLK input should be at right exit to trigger the counter to decrement. We'll name it left exit, and the triggering input is input 0.5, which we will get from the tag list. We also need its Q for a normally open contact. Again, we'll get that from the tag list. Let's scroll down. Okay. Then we can add the compare function to check the CV value of the left counter. We'll get that from the bank instructions under compare operations. Again, let's look at the tag list. There we go, and enter 0 to compare it against. Let's then link it to the countdown input on the counter. Okay, that's it for that network 4. Okay, let's go down to the outputs network and add a couple of branches here too. Again, copying some of the existing logic. Now, just so I can keep things consistent, I'm going to insert a branch above the compare function. I'll cut the compare first, then paste it back in afterwards. Edit, then cut. Now let's copy the branch above, but this time for transferring left. Enter a normally open contact and address it M0.3 for transferring left, and then an output coil to engage the transferring left yellow bed and chains. Let's find that in the tag list. Scroll down and select output Q0.3. Now let's paste back in the right conveyor output by creating a new branch, then paste. Then we need another one like it for the left conveyor motor. Select the edge and create a new branch. Then bring down the compare function. Select the counter, then its CV, then compare it to 0. Then add an output coil and address it Q0.5 for conveyor left. Virtually finished now. Just one last thing to do, and that is to go back to the very first network and add another move function to initialize the conveyor left counter at startup. Up we go, just checking what we've entered as we go along. All networks look okay. So in network 1, let's add a branch under the move function and extend it down further. Bring down another move function, and this time move 0 into CV for the left conveyor counter. So 0, and from the tag list select the left conveyor counter and its CV. Right, we're ready to download the ladder logic to the PLC and test our program. Let's reinitialize the data blocks and load. The moment of truth is almost here. Let's go online and start monitoring. Always seems to take forever when waiting to check your program. Yep, we are in monitoring mode. Now in FactoryIO, I've just got to allow the emitter to produce some small palletizing boxes as well as large boxes. I'll also increase the amount of boxes being produced in a time frame. Okay, we're ready to go. Run FactoryIO and let's see what happens. Oh, a small box right away on the entry conveyor. All being well, this should go to the left, which it does. And the next box is a high box, so that should go to the right. Yes. Let's check the next small box, and it all seems to be working fine. I think we should stop FactoryIO and increase the number of boxes even more. So let's do that. Right click on the emitter, select minus to decrease the time between boxes. Okay, let's try again. That's better. Lots of boxes coming through. Yep, small boxes to the left and large ones to the right. Let's see the next small box. Yep, to the left. And the next high box to the right. That all looks fine, so I'm going to stop FactoryIO now and come offline on the TIA portal. Not forgetting a very important thing, and that is saving the program. That's all for this video. In the next video, we'll be looking at making use of the buttons on the panel to control the conveyor system. Until then, if you like what you've seen and would like to see more, then please click the subscribe button, and I'll see you in the next video. Thanks for watching and see you shortly.